Hello guys, let's talk about vapor pressure. But first, let's think of a really hot summer day. Let's say that we left outside a glass of water. What happens to it in a few hours? Well, it's gonna warm up and eventually the water will completely evaporate. So this means that when we have a liquid in an open container, at any point of time, some of the liquid molecules are going to leave into the gaseous phase and actually leave our container and just fly away. And it makes sense that as the temperature increases, this evaporation process is going to get faster and faster. Now, what happens when my container is closed? I will still have these molecules in the liquid phase that will start to evaporate. However, at the same time, from the gaseous phase, there will be molecules that will start to condense back into the liquid phase. And the pressure exerted by these gaseous molecules in equilibrium with the liquid in a closed container is actually called the vapor pressure. And as I said, it makes perfect sense that as the temperature increases, the vaporization process is going to get faster and faster, right? So, if you think about it, at atmospheric pressure, if the vapor pressure of the liquid equals to the atmospheric pressure at a given temperature, the liquid will boil. And that is the boiling point of a liquid, the temperature at which the vapor pressure equals to the atmospheric pressure. On this graph, we can see the vapor pressure given in torrs and the temperature, and two lines. One of the lines is the blue line for water, and the other line is the orange line for diethyl ether. Now, if you look at 760 torrs, which is actually the atmospheric pressure, you are going to see that at this point, the vapor pressure is also 760 torrs. So the vapor pressure equals to the atmospheric pressure at 100 degrees Celsius for water, where water will boil. Now, what happens to diethyl ether, this huge molecule right here? What is its boiling point at atmospheric pressure? It's actually 34.6 degrees Celsius because at this temperature, the vapor pressure of diethyl ether equals to the atmospheric pressure. All right, now, does this make sense? Where do we have stronger intermolecular forces? We know that in water, we have hydrogen bonding, which is the strongest type of dipole-dipole interaction, right? How about diethyl ether? Do we have London dispersion forces there? Yes, we do. Is this molecule polar? So we would have dipole-dipole interactions? Well, it's actually non-polar. Although the CO bond is polar, but because it is symmetrical in the molecule, the overall molecule is going to be nonpolar, so we are only going to have dipole-dipole interactions as intermolecular forces between diethyl ether molecules. So it makes sense that it will boil at lower temperatures. So its vapor pressure is going to be at lower temperatures equal to the atmospheric pressure. Now, another question. What if the atmospheric pressure would equal to, let's say, 400 torrs? So 400 torrs is right here. Then I could extend this through here and actually see that at 400 torrs, diethyl ether would boil at 20 degrees Celsius and water would boil at about 70 degrees Celsius. I hope this makes sense. See you in the next video.